Find any critical values of the second derivative for the following function. F of x is equal to e to the negative x squared. All right, so in order to get to the second derivative, first we have to find the first derivative. So f prime of x is going to be, the derivative of e is e, but we do have an exponent that is different from regular x. So we keep e to the negative x squared, but because that exponent is something different, we have to take the derivative of the exponent by the chain rule, and the derivative of negative x squared is negative 2x. So therefore, f prime of x is equal to negative 2x times e to the negative x squared. All right, now we have to find the second derivative. And in order to find the second derivative, we're going to have to apply the product rule. And the product rule says the second, that's e to the negative x squared, times the derivative of our first, which is the derivative of negative 2x, so that's going to be negative 2, plus our first, which is 2x, negative 2x, sorry, times the derivative of our second. And that derivative is going to be the negative 2x e to the negative x squared that we found before. And then if we simplify this, we will have that f double prime of x is equal to negative 2 times e to the negative x squared, and then it'll be plus 4x squared e to the negative x squared. So now we have our second derivative. And now to find our critical values, we need to set our second derivative equal to 0. So let's do that as the next step. So we have that 0 is equal to, we can pull out an e to the negative x squared from both terms. When we do that, we will be left with a negative 2 plus 4x squared. And if we wanted to, we could factor out a 2 as well. And let's actually do that real quick. So let's also bring the 2 out. E to the negative x squared. And then I'm also going to reorganize these. I'm going to put the 4x squared, which is now 2x squared, in front. And then the negative 2, when we pull a 2 out, we're left with negative 1 or minus 1. All right, so now if we think about e to the negative x squared, e can actually never be equal to 0. If you have positive and negative exponents, it just moves e to the top and bottom. So therefore, what's factored out has nothing to do with our critical values for the second derivative. It all has to do with what's inside of the parentheses here. So if we set 2x squared minus 1 equal to 0 and solve, we'll get that x squared is equal to 1/2. And then when we square root both sides, we get that x is equal to plus or minus square root of 2 over 2 when we rationalize, making Roman numeral 7 and Roman numeral 6 the possible or the critical values for the second derivative, which is answer choice D.